Hi, my name is Avani Reddy, and this video is an analysis of an object moving at the same speed without changing direction. A lacrosse ball was recorded rolling across a table, and then the video was imported into Tracker. The diameter of the ball was added to the video to provide a reference to the size of the surrounding objects, or a frame of reference. An axis was then added, centered on the middle of the ball's initial position. The ball moves in the positive x direction on the axis. If the axes were to be flipped, the data would just become negative, but the concluded results would be the same. This is why it is important to label axes so that others can understand the results of data. Frame by frame, the ball's position was calculated in Tracker. Using this data, a model was produced, coded in Python to graph and predict the ball's position versus time. Data specifically used was the ball's total time traveled, initial position, and initial velocity. Initial velocity was calculated using the formula average velocity equals change in distance over change in time, with the first two position points recorded on the tracker being the points used in the equation. This is the initial position. This is the initial velocity, calculated in the experiment. Within the code, Newton's second law was used to produce the virtual model. Newton's second law, or the momentum principle, is used to predict the behavior of objects. The principle states that momentum equals the net force times the change in time. Since there is no change in acceleration because the velocity is constant, the net force is zero. In the velocity equation of v final equals v initial plus force divided by mass times change in time, the force would be zero, showing that the final and initial velocities are the same and would be constant. To calculate the final position, the equation r final equals r initial plus the average velocity times the change in time is used. The final velocity from the previous equation is used as the velocity in this equation. This calculates the distance moved over the change in time for the predicted model as the code iterates over less than 1.583 seconds, the experimental time period. The time period is shown here. Newton's second law is shown here. These are the predicted model results. The data from Tracker was graphed against the data that resulted from the Python code. This relationship shows the difference between the experimental data and the predicted data, or what actually happened versus what should have happened. The experimental data, the blue dotted line, has a positive linear relationship. The model data has the same relationship. This shows that the model predicts and the data proves that the object moved at a constant rate in the positive x direction. However, the experimental data does not match up with the predicted data after about 0.375 seconds because the velocity is decreasing over time, meaning a negative acceleration. The model predicted an acceleration of zero since the net force was assumed to be zero. The experimental model differed most likely due to the force of friction and air resistance and drag. The pushes and pulls that add up to the net force of zero cannot be calculated in the experimental data for this reason. There are too many other forces like gravity, friction, drag, and air resistance to consider.